Saya lari pergi farmasi. So sorry. Oh. Assalamualaikum, good morning. Thank you for joining. Okay, so hopefully pagi ni saya tak ada problem kes malam. Okay, so pagi ni kita akan habiskan kita punya eksperimen. Saya share screen dulu. Alright, so pagi ni kita akan habiskan kita punya eksperimen. Kita ada determination of pH, determination of friability, and also determination of absorption maxima and calibration curve using UV visible spectroscopy. The first two tu, pH and friability, kita sepatutnya buat semalam, tapi ada problem with my Microsoft team, so saya akan repeat lagi sekali lah pagi ni. Saya kenapa dia tak keluar? Kamu nampak kan saya share screen because I can see the red marks. Okay. Okay, as I was saying, determination of pH. Kalau kamu tengok dalam lab manual kamu, experiment number 5, the objective of this experiment is to determine the pH of all the given samples. So why do we need to test for pH? This is so that we know that the medication, the drugs that we are testing will be as efficient as it should be, because some some drugs will be efficient at certain pH. Okay, because for example, selalunya macam ubat to treat gastric, omeprazole. So omeprazole, it can be effective at the most acidic pH dan juga most basic pH. Okay, because bila kita sakit perut, the gastric juice dalam kita punya perut, the shift lah towards either very basic ataupun very acidic. So the drugs that we are eating to treat that problem mesti be efficient dalam keadaan tersebut, most acidic ataupun most basic. So kalau the pH tak sesuai, the pH of the drug yang kita makan tu tak sesuai dengan keadaan pH dalam badan kita, it will not be as efficient. Maybe dia akan take a longer time to work, okay, ataupun dia mungkin tak berkesan langsung. So that's why kita mesti make sure the pH is correct. Yeah. So kena admit all of your friends. So before kita proceed with the rest, saya nak share a video. But first let me shift the screen sharing to window only. Experiment. Oh. Include computer sound. Spam on this one. So the pH test adalah makmal kalau kita boleh masuk lab, kita selalunya saya akan bagi 3 samples using a pH meter. So I'll be sharing a video which you can access yourself dalam Google Classroom. for the purpose of this class demonstration, saya nak tunjuk live.
pH meter. pH meters can be small and handheld or larger stationary pH meters. In this video, we will be using a stationary pH meter. The parts of a pH meter include the meter, the arm, and the electrode. The arm allows the electrode to be easily moved up and down into a beaker for the sample to be tested. Prior to use, a pH meter should be calibrated using color-coded buffers at a fixed pH. pH 4, 7, and 10 are standard. The first step in using a pH meter is to remove the protective cap from the electrode.
Okay, so saya nak explain about this pH standards buffer solution. So before we begin any pH determination, kita perlu calibrate dulu our pH meter. So the purpose of why we are calibrating our pH meter is to make sure that our pH meter is working as it should. Okay, so as you can see dalam on the label of the standard buffer solution, kita ada 3 different pH, pH 4, pH 7 and pH 10. So pH 4 is for testing the acidic condition, pH 7 is for neutral, pH 10 is for basic. So kita nak pastikan kita punya pH meter tu boleh detect this pH correctly. So you just think of it as macam kamu, kalau kamu ada kamu familiar with kereta, sometimes at a certain period after dah guna for a couple of months, kamu kena hantar kereta untuk service, tukar minyak enjin, tukar oil filter. Okay, so the purpose why we are doing that is to make sure that our car is working in a good condition. Dia apa nama, dia punya fuel efficiency, dia tak pakai minyak banyak. Okay, dia enjin tak cepat panas. So kalau if the car have that problem, maybe you should send it for service because it's not working as it should have. Okay, so that's the purpose we are calibrating our instruments before we use them.
A pH meter should be calibrated using color-coded buffers of fixed pH and are standard. The first step in using a pH meter is to remove the protective cap from the electrode. The electrodes of the pH meter need to be stored properly, capped and immersed in a storage solution to prevent them from drying out. Next, the electrode must be rinsed using distilled water. Various pH meters will have different procedures for calibration. To calibrate your pH meter, you will need to review the owner's manual for the proper procedure. Begin the process of calibration using the standard with a pH of 7. Once the standard has been calibrated, you will need to remove the sample and rinse the electrode with distilled water.
So as you can see, the process of calibration ni hanyalah kita we are only taking the reading of those buffer solution, standard solution. Maksudnya kamu ambil, you tuang pH 7 punya buffer solution, tuang dalam beaker and then ambil bacaan pH tu. So kalau bacaan pH tu sama seperti yang tertulis dalam label, so that means your calibration is going okay lah. Okay, kalau pH 7, kalau pH buffer solution tu pH-nya 7, bacaan pada meter kita pun mesti keluar 7. Kalau kita test pH buffer 4, bacaan yang keluar pada meter pun mesti 4. Kalau kita test buffer solution 10, pH yang bacaan pH pada meter pun mesti 10. So that is calibration of the pH meter. Kita ambil bacaan of a standard solution. So that's why it is important you have a standard solution, standard buffer solution. Meaning kita punya solution tu pH dia disediakan pada at a certain pH. And also, as you can see, sepanjang proses calibration ni, setiap kali dia tukar solution, dia akan rinse. Okay, kalau dia nak test pH 7, dia rinse dulu, baru dia dip the electrode into the solution. Bila dah selesai, dia rinse balik, baru dia dip into pH 4 solution. Okay, so this is important so that kita tak contaminate kita punya standard solution. And afterwards,
solution beneath the electrode and slowly lower the arm so that the electrode is fully submerged in the solution.
So it is important that kita rendamkan electrode itu sepenuhnya dalam kita punya test solution. Tapi make sure jangan bagi dia bersentuh dengan the bottom of the glassware. Kita tak nak ada sebarang kerosakan pada kita punya electrode. So after the reading on the meter dah stabil, you take it, you record it in your book. Then that's it. You rinse it, then you can proceed with another reading ataupun simpan lah, store balik punya storage solution. So it's very simple this test. Kalau dalam makmal, sekejap somebody. So pH meter is very simple. You just need a few setups, a few glassware, and your test solutions. So kalau kita buat ni dalam makmal, saya akan sediakan 3 samples. Selalunya sampel yang pekat macam cream ataupun suspension, dan sampel yang cair macam salbutamol solution, diphenhydramine solution, buat batuk, buat semua. So the idea is kalau kamu punya solution tu terlalu pekat, contohnya macam aqueous cream, you will need to do some dilution first, meaning kamu kena cairkan dia. You take a few grams, contohnya macam take 1 gram of aqueous cream, masukkan dalam conical flask, kemudian kamu dilute, kamu tambah like a few ml, 50 ml ataupun 100 ml of solvent, usually it's water. Kemudian kamu kacau dia, bagi dia bercampur, dissolve completely, and then kamu boleh ambil bacaan pH. Okay, this is because saya kena share screen balik. This is because pH meter takes the pH meter measures the amount of hydrogen ion yang ada dalam kita punya solution. Okay, so if you take a look at the principle, pH is measured using a pH meter. This value well accords with the logarithm of the reciprocal of hydrogen concentration in dilute solution. So kat sini dia kata bacaan pH tu is based on the amount of hydrogen ion yang ada dalam kita punya test solution. So the idea is the electrode yang kita celup tu, dia akan ukur, dia boleh detect berapa banyak hydrogen ion yang ada dalam kita punya solution. So kalau larutan kita punya tu terlalu pekat macam cream, so dia tak boleh detect the hydrogen ion yang ada because hydrogen ion tak boleh terhasil sebab tidak ada solution. Okay, ions usually exist in dilute solutions. Bukan exist, easily detected. Okay, itu description yang lebih tepat. Ion lebih mudah dikesan dalam keadaan di dalam larutan. Okay, so that's why it is important kalau kita punya sample tu terlalu pekat macam cream ataupun suspension, it is best that you dilute the sample first. So that's why kamu kena ambil a few grams of the cream, dissolve dalam solvent, kacau dia, bagi dia sebati, and then baru ambil bacaan. Because that's how pH works, pH reading works. So this is what kamu dah belajar dalam semester 1 dalam physical chemistry. In case kamu terlupa, this is the formula, the logarithm. pH equals to negative log of the concentration of hydrogen ataupun the concentration of hydronium ion. Okay, kita measure kepekatan, the amount of hydrogen ion dan juga the amount of hydroxonium ion. So the pH meter yang kita guna tu, this is the algorithm that is programmed into the meter. So they translate from the electrode to the meter reading using this equation. Okay, so the purpose why we want to make sure the pH is correct, because kat sini saya tulis make sure the efficiency of the medication as good as it should be, and also for safety reasons. Kita nak make sure pH tu tak terlalu berbahaya untuk patient selamatkan. So the procedure yang ada dalam lab manual ni sama macam dalam video yang kita tengok tadi. Okay, kalau perlu, kalau kita ada sampel yang perlu dicairkan, kita cairkan dulu, perlu proceed with testing. Kalau dah sedia memang cair, terus proceed with testing. And how do you report this? Adalah dengan just write down the pH dan keluar pada meter. So kalau pH tu macam tadi dalam video 5.77, tulis the pH of the given sample is 5.77. Okay, the materials and instrument is straightforward macam dalam video tadi. Kamu perlukan pH meter, beakers for rinsing, volumetric flask untuk prepare any dilution of sample, and samples of organic compound. Alright, that's it untuk pH meter. Next, saya nak move on to friability, experiment number 8. Okay, 6 and 7 kita akan buat afterwards because they are spectroscopy, the same experiment. So nak make sure I'm still in the okay. Okay, so friability. What is friability? The word is basically to describe the ability of tablets to withstand damage, to withstand abrasion. Okay, but this testing is required because in the beginning of pharmaceutical industry dulu, bila ubat-ubat ini dah siap di pack, dah masuk dalam blister, dah masuk dalam carton, dah masuk dalam boxes, ready for transport, dah letak di hospital, pharmacies and clinics all around the country. Bila ubat-ubat ni go through all this routes untuk sampai ke destinasi, dia akan lalui pelbagai jenis bentuk condition of the road, sometimes bumpy, jalan tak rata, so dia akan bergegar. So bila berlakunya gegaran ni, ubat-ubat yang dalam lori itu dia akan berhentak antara satu sama lain. Kotak-kotak yang dulu akan bergerak, dia akan vibrate. So the problem is bila dia sampai pada destinasi, some of the tablets akan pecah dan berpecah. So it cannot be consumed. So rugilah. Okay, so to avoid this, kita make sure the compression is good masa dalam production. And to make sure, how do we know the compression is good, the punya strength of the tablets are good or not, kita buat friability test. So that's why the punya objective is to determine the friability of given tablets to withstand damage, the ability of tablets to withstand damage. So how do we perform this test? Let me share the screen yang boleh dapatkan audio. This one. Oh, I forgot that. Include computer sound, window, experiment. All right. So friability, determination of friability. So it's just a 2-minute video. So this is what a friability tester looks like. Dia ada satu drum besar, that circle. So dalam drum tu, this is where we put our tablets in. And also if you notice, dia ada macam satu scoop kat sini. So the idea is bila kita masukkan tablets dalam drum tu, the drum will rotate, dia akan pusing, and dia akan baling our tablets to the bottom of the drum. Dia akan pick up the tablets and dia akan baling at the bottom. Let me rewind sikit. So how do we perform this test? What is the procedure? So berapa banyak biji tablet yang kita nak test? So ada dua condition kat sini. Okay, condition pertama, if the average weight of the tablet is 0.65 grams or less, you take the quantity of the whole tablets that correspond to about 6.5 gram. Maksudnya, kalau average of the tablet is 0.65 gram or less, kita ambil just, doesn't matter how many tablets, but just make sure the total will amount to 6.5 gram. Make sure the total weight of the tablet must correspond to 6.5 gram. Okay, and if the average weight of the tablet is 0.65 grams or more, you take 10 tablets. So the thing that you have to know is bila production dah siap buat satu batch ubat, dia dah buat satu batch tablet, dia akan hantar like a few tablets, 50 to 100 tablets to QC lab for testing. So bila dia sebelum dia hantar tu, dia mesti measure dulu each of the tablet weight dia berapa. Dia akan take like 30 tablets randomly, dia akan masukkan dalam this machine, auto tester kita panggil. So this machine boleh timbang automatic dia akan timbang 30 tablets each, dia punya berat berapa. Yang kita boleh dapatkan the average weight from that 30 tablets. So if the average weight of the tablet kat sini, dia kata kalau average weight of tablet is 0.65 gram and less, kita ambil seberapa banyak biji tablet, janji berat dia total amount to 6.5 gram. Kalau the average weight of the tablet is 0.65 gram and more, kita ambil 10 biji tablet. So basically secara kasar kita ada dua condition. Kalau tablet tu kecil, kita ambil, kita timbang berat sampai 6.5 gram. That's the much. That's our testing our testing sample. Kalau tablet tu besar, kita ambil 10 biji saja, tak perlu timbang. Okay, so contohnya kalau kamu ada kamu nak test Panadol Activas 650 mg. So tak perlu timbang. The average tablet weight is 650 mg and more. So ambil 10 biji je, terus buat friability test. Kalau ubat yang kecil macam chlorpheniramine 4 mg, okay, yang itu kamu kena timbang dulu. Kamu kena take how many tablets it takes to amount to 6.5 gram. And that's the amount that kita akan guna for testing. So, kita take initial weight, ambil berat dia 6.53 gram. And then kita set time duration for 4 minutes. Set the number of count for one. Count ni maksudnya berapa kali dia nak pusing, rotation. So, masukkan the tablets into the drum. Okay, lock it in, tekan start. So, the drum akan rotate lah. So, as you can see dalam video ni, dia akan pick up the tablets at the bottom, bawa pergi atas and then drop. So, this is to imitate the movement dalam lori. Bila kita hantar dalam inilah airplane ke lori ke, bila ada gegaran, hantarkan. This is to imitate the movements. So, bila tablets ni dibaling dalam drum ni, akan berlakulah sedikit macam pecahan. Okay, the tablets will be chipped a little, pecah sikit-sikit. So kat situ kita boleh tahu. Kita boleh tahu berapa banyak yang pecah by measuring, timbang the final weight. So timbang the final weight 6.443. So now we can calculate the friability. So this is the formula. Kamu ambil initial weight, tolak final weight, bahagi dengan initial weight, darab dengan 100. Kita akan express, kita akan express the friability dalam bentuk percentage. Okay, so initial weight tadi 6.536, tolak final weight 6.443, bahagi dengan initial weight dengan 100. So the final answer, the friability is 1.42%. So inilah berat, peratus berat yang pecah, yang hilang from the original weight. Okay, 1.42%. So how do we know whether it passes or fails the test? So kita tengok pada dia punya specification. So value of friability should not be more than 1% for most tablets. So kalau more than 1%, pecahan tu lebih daripada 1%, maksudnya the tablet fail the friability test. So in case kalau fail, dia kata kat sini, second point, if the value of friability is greater than 1%, then repeat the test twice. ulang 2 kali. Maksudnya kamu kena pilih lagi, timbang 6.5 gram of tablet again, buat lagi sekali test tu, and then timbang the final weight. Buat 2 kali and take the mean value. Okay, mean value meaning kamu ambil value yang di tengah-tengah. Later saya akan explain apa maksud mean kalau kamu not sure. So if the mean value of the 3 tests is less than 1%, tablets passes the friability test. Kalau fail, maksudnya kalau more than 1%, maksudnya fail. So you have to investigate. Something is wrong with the batch. Tengok balik dalam production kat mana silap. Okay. So if the tablets are broken, chip or cracked during the test, kalau ada yang macam broken, chip yang terlalu besar, crack during the test, the tablets fails the friability test. Okay, doesn't matter kalau ada punya ni less than 1%. Kita tak mahu ada tablet yang pecah, crack, terbelah dua. Okay, so dalam video tadi dia ada tunjuk, dia kata you have to take the mean. Kalau let me share the screen dulu. Mana pen saya? Okay. Okay, determination of friability. Okay, our goal, kat sini saya tulis, our goal is to get less than 1% of weight loss. So dalam video tadi kita dapat 1.42%. So this is more than 1%. So that tablets yang kita test dalam video tadi tu fail. So kalau fail, dia kata kita kena repeat twice. Okay, repeat the same test 2 kali and then we take the mean. So what does this mean mean? So this is katakanlah this is friability number 1 and then kita repeat the test, kita dapat 0.98% and the third one kita dapat 0.96%. So what is the mean? So mean bukan bermaksud average. Mean kalau kamu ada set of data 3 macam ni, this is data number 1, friability test number 1, this is number 2 and number 3. Mean bermaksud set yang data yang terletak di tengah-tengah kalau kita susun ikut order. So as you can see from our data, kita ada saya dah susun ikut turutan kat sini 0.96 and then 0.98 dan 1.42. Mean reading is the data yang terletak di tengah-tengah. So 0.98 is the mean. So this is the one yang kita ambil untuk determine whether the tablet pass or fail the test. So kalau kita punya goal is to get less than 1%, so the mean friability yang kita dapat tadi adalah 0.98, which is less than 1%. So this tablet passes the friability test. Okay, remember you only need to repeat kalau the first reading is more than 1%. Kalau bacaan pertama is less than 1%, no need to do lah this second and third test. Alright. So untuk friability test, that's basically it. Kamu hanya perlu determine the amount of weight loss. You express it dalam bentuk percentage. So this is how do you report kalau kamu buat this test dalam lab lah. Okay. So let's take 5 saat. Saya dah tegak the thing. I'll come back in 5 minutes untuk continue with experiment 6 and 7. Yes, determination of absorption maxima.
sample is dissolved in a suitable solvent. It is important to check that the sample is completely dissolved. The cuvette should be filled until about 3/4 full. It is important to ensure that the clear faces of the cuvette are clean. The cuvette is carefully stoppered. To run a spectrum, the correct method must be selected using the spectrometer's finger pad. The cuvette must only be held by the frosted or textured sides. Fingerprints will interfere with the results of the spectroscopy. The spectrum is recorded.
Okay, so that was a short video about using the UV-vis spectrophotometer. So what is exactly UV-vis spectrophotometer? Let me rewind a bit. Silap. People are waiting in the lobby. Where's my... Somebody is in the lobby. Somebody, Nurul Zafira, selamat datang. Okay, UV visible spectroscopy. What is it? Before kita go through the experiments, saya nak explain sikit what is UV vis spectroscopy because tak ramai orang familiar with this. Kita dah belajar ni dalam first semester, tapi I figure mesti dah lupa kan. So spectroscopy, as you all know, light is a spectrum. Cahaya yang kita nampak ni is a spectrum. Kita ada wide range of light yang kita nampak and light yang kita tak nampak. Okay, the ones yang kita nampak is just a small portion, iaitu visible light. Visible light. Okay, this is the electromagnetic spectrum. It ranges from very small, saya pun tak ingat berapa. I want to say 0.01 nanometer to like tens of thousands. So, sorry, 1/10 katakanlah, it's very big, okay? 1/10 nanometer. So nanometer is a unit for wavelength. Kita guna unit ni untuk measure the spectrum, electromagnetic spectrum. So the ones that we can see adalah visible light. Okay, cahaya kita nampak dengan mata kasar kita. The ones that we don't see adalah contohnya macam gamma ray, which is very big. It's here. What's the symbol for gamma? I think this is good. Never mind, so to this gamma. Gamma ray, my bad. Gamma ray, kita ada X-rays, kita ada apa lagi? Kita ada radio waves, kita ada ultraviolet is after visible light, UV light. In the beginning ni ada some more, I forgot. But this is the electromagnetic spectrum. In the ones that we can see adalah visible light. This is about 200 nanometers. Saya tinggal bawah lah. Okay, visible light ranges from 200 nanometer to about 800 nanometer. Very small spectrum of light that we can see. This is the one yang kalau kamu zoom out, if you Google visible light, kamu akan dapat all the rainbow colors. Okay, dia saya nak mungkin kamu okay, kamu akan dapat all this rainbow color. Dia punya wavelength bacaannya 200 nanometer ke 800 nanometer. So the thing, why am I telling you this? This is because molecules dan atoms can absorb and emit. Dia boleh serap dan dia boleh pancarkan balik. Okay, so this is just the behavior of atoms. Okay, the reason why we see colors. Okay, kenapa kita nampak certain colors? It is because objek tu serap cahaya yang lain dan dia pancarkan cahaya tersebut. So then why do we see bunga raya warna dia merah? Sebab dia serap all the other colors. Cahaya yang ada dalam pelangi tu, dalam the visible light, dia serap all the other colors dan dia pancarkan warna merah. So pancaran tu bila masuk dalam mata kita, that's what we see. Okay, kalau kita nampak baju warna biru, that is because the fiber of the baju absorb all the other colors and dia pancarkan warna biru. So that's why we see colors. So this is the behavior of atoms and molecules. They have the ability untuk absorb radiation, iaitu cahaya, and dia boleh pancarkan balik. So this behavior does not only apply to visible light sahaja. Okay, dia tak limited only to visible light. Dia apply to all the electromagnetic spectrum. Electromagnetic spectrum. So molecules and atoms boleh absorb gamma ray, X-ray, radio waves, UV, visible light, and dia boleh pancarkan balik cahaya-cahaya. Okay, so this is the behavior of light. So in analysis kita bukan manipulate, kita guna pakai this behavior sebagai satu trait, identification trait. Kita boleh gunakan sebagai satu trait untuk kenal pasti, because certain objects, certain molecules, certain atoms will only absorb certain range of light saja, and dia akan pancarkan balik certain wavelength of light saja. Sama macam color tadi lah. Okay, so these colors contohnya, saya tak ingat warna pelangi dia punya susunan macam mana. Just katakanlah this is the red. Okay, katakanlah ada warna yellow, blue, violet, red, orange. I forgot the rest. Ada green. Apa lagi satu? Saya tak ingat. Minit-minit ada orang dalam lobby. So, macam saya cakap tadi, bunga raya. Bunga raya, hibiscus. Kenapa kita nampak dia warna merah? Because dia absorb all the other colors and dia pancarkan balik, dia emit warna merah. Selebihnya warna yang lain ni dia serap. So that's why we see bunga raya warnanya merah. So this is penama kita guna this trait as sebagai some molecules in bunga raya tu, they absorb the dominant molecules yang ada dalam bunga raya tu, they absorb all the other colors and they reflect, they emit only a red color. So that's why we can use this trait of molecules and atoms untuk kita kenal pasti, because they have certain preference untuk serap dan pancarkan certain wavelength of light. So that's why in chemical analysis kita boleh gunakan this behavior of atoms and molecules untuk serap dan pancarkan cahaya ini sebagai dia punya ciri-ciri untuk kita kenal pasti. Contohnya carbon molecules. Carbon molecules maybe dia serap around 200 nanometer wavelength. Paling banyak dia serap wavelength ni. Maybe apa lagi, kalau carbon tu dia bergabung dengan satu hidrogen, dia serap paling banyak dekat 230 nanometer. Dia punya ability untuk preference untuk serap changes kalau dia bergabung dengan other atoms. Kalau dia ada 1 to 4 hydrogens, maybe dia serap paling banyak dekat 260 nanometer. Kalau dia ada oxygen CH3O, maybe dia serap paling banyak dekat 300 nanometer. So we can use this trait of atoms and molecules ni untuk serap cahaya sebagai ciri-ciri untuk kita kenal pasti. So that's why dalam analisis, kalau kita ada contohnya kita nak detect the presence of paracetamol, the API untuk Panadol, paracetamol. So kalau kamu tengok dalam kalau kamu Google the molecules for paracetamol ni, it contains nitrogen, it contains carbon, it contains oxygen, it contains hydrogen. So maybe dia ada certain preference lah untuk absorb a certain wavelength of light. So katakanlah kita tahu, kita test lah all different wavelength, dia absorb paling banyak dekat mana. So katakanlah dia absorb paling banyak dekat 270. So kita boleh gunakan this behavior untuk kita kenal pasti. So kalau dalam makmal, production department hantar satu batch ubat Panadol. So kalau kita nak identify betul ataupun tak betul itu adalah Panadol, kita boleh buat spectroscopy test. Kita grind dia jadi powder, dissolve dalam solvent, and then masukkan that solution dalam UV spectrophotometer, dan tengok dia absorb light paling banyak dekat berapa nanometer. So kalau absorption dia paling banyak dekat 270 seperti yang dah tertera dalam pharmacopoeia, so that means kita boleh buat conclusion lah, ubat yang kita test, tablet yang kita test itu adalah paracetamol, because the wavelength yang dia serap paling banyak adalah 270 nanometer, sama yang macam ada dalam pharmacopoeia. Okay, all kita refer back to pharmacopoeia. So that's why going back to your lab manual, the objective of experiment number 6 ni, determination of absorption maxima of potassium permanganate. Tujuannya adalah untuk kita determine the absorption maxima. So kenapa kita nak determine absorption maxima? Macam saya cakap tadi, certain molecules, certain atoms absorb a certain range of wavelength of light. So kita boleh gunakan ciri itu sebagai satu ciri untuk kita kenal pasti bahan itu adalah apa. Okay, so the principle kat sini dia tulis lambda max is the wavelength at which maximum absorption of the radiation takes place. So kita nak determine the lambda max. So how do we determine the lambda max? The lambda ni is the wavelength. Okay, lambda is a uniform wavelength. So macam mana kita nak buat test ni? Kita perlu prepare a solution of potassium permanganate. Okay, and then kita akan test at different wavelength. Kita start from 410, 420, naik by the power of 10 lah, sampailah 700. So kita buat testing satu-satu. We use the same solution, tapi kita test dekat different wavelength, and then kita measure dia punya absorbance. So the idea is kita nak cari absorbance yang paling tinggi. So kat sini kalau kita tengok pharmacopoeia, maybe dia kata expected max is to be 530 nanometer. So maksudnya kalau kita dah ambil bacaan for the absorbance for all this wavelength, kita expect bacaan paling tinggi, bacaan absorbance paling tinggi adalah pada 530 nanometer. Meaning kita expect potassium permanganate untuk serap radiation paling banyak dekat wavelength 530. So kalau bacaan kita dapat itu betul, concur with our expectation. So that means betul lah that sample yang kita prepare, yang kita test tu adalah potassium permanganate. Tulis dia tak banyak impurity ataupun tak ada impurity. So how do we report this test adalah dengan tulis the absorption maxima of potassium permanganate is berapa absorbance. Selalunya the bacaan will be 0. something lah. 0.563. How do we perform this adalah macam dalam video yang saya tunjuk tadi. Ini saya share screen ke? Saya share window. Don't know. Let me share screen terus. Saya share lab manual tadi, kamu nampak ke tak nampak? Okay, saya tak pasti kamu nampak atau nampak tadi. So this is what, saya dah cerita panjang-panjang, this is what I mean lah. Okay, so kalau kita nak test potassium permanganate, we prepare a dilute solution. And then kamu test the solution at different wavelength. Kita start from 410, 420, 430 sampai lah 700. So naik sikit-sikit, naik by 10. 410, tambah 10, 420, 430, 440 sampai lah 700. So the expected, kamu tengok dekat point number 5, the expected absorption maxima is at 530 nanometer. So around here, the absorbance should be the highest lah, 530. So the absorbance here should be the highest. Mana the spectroscopy analysis lah. This is the one yang saya tunjuk tadi. So dalam video, this 1 minute video, it shows how to operate a UV visible spectrophotometer. So dalam this video, dia cerita kamu mesti prepare a solution. Okay, you have to, whatever samples you have, tablet ke suspension ke apa ke, you have to dilute it into a solution so that pH, so that this instrument boleh function as efficient. So this tube, this cuboid yang kamu nampak ni, this is called a cuvette. Okay, a cuvette is just a compartment yang mana kita masukkan our sample solution. So as you can see, the sample solution is the cuvette, C-U-V-E-T-T-E. The cuvette is either made from the cheap material macam glass, silica, the mahal ones are quartz, crystal, tapi janji the clear. Okay, it's a clear surface so that the light radiation can pass through our solution. Okay, kita nak make sure kita punya solution ni boleh menyerap cahaya. So this is called a cuvette. We fill in the cuvette with our test solution, and then we will put the cuvette into our spectrophotometer. Excuse me. So how does this thing work? I can go in detail lagi dalam chapter 6 our lecture class. Okay, but basically how does this thing work adalah dalam this machine, dalam this big bulky part here, ada satu sumber cahaya. Okay, kalau kita masukkan kita punya cuvette dalam dia punya compartment dekat dalam instrumen ni, so kita masukkan kita punya cuvette kat situ. So basically dekat somewhere around this cuvette ada satu macam lampu sumber cahaya. So a radiation of light akan dipancarkan through our cuvette, menembusi our cuvette so that the solution can absorb some of the light. So at the other end of the cahaya, katakanlah kat sini ada lampu. So dia akan pancarkan, dia akan tembak this cuvette with the solution. So at the other end, kat sini ada macam satu detector. Dia akan detect the light that passes through the cuvette. So dia boleh measure berapa banyak cahaya yang diserap. Because bila go through a whiteboard set. Okay, so this is our light source. This is our cuvette with solution. So this is a detector. So this is our solution and this is our detector. So bila cahaya pass through our sample, the thing that will happen is solution kita ni akan absorb some of the light. So the light that passes through akan jadi less intense. Okay, I'll describe the intensity by the amount of light, by the amount of lines yang ada di sini. So intense ni kat sini maksud saya macam cerah lah, kecerahan. So katakanlah kecerahan pada in the beginning sangat tinggi. Tapi bila dah dia menembusi kita punya sampel ni, kecerahan cahaya tu semakin kurang. Kenapa kecerahan dia semakin kurang? This is because the solution will absorb some of the light. Okay, that's the idea. Kita nak measure that absorbance. How do we measure that absorbance? Kita ada satu component at the end ni, it's known as a detector. So dia boleh detect lah. Dia boleh measure, dia tahulah the intensity, the initial intensity is berapa, how much. So bila dia detect the amount of light yang passes through the solution, dia boleh detect and then dia boleh calculate. So that's how we get bacaan absorbance dekat kita punya meter. Kucing ni duk kacau sebenarnya. So that's how the instrument knows the absorbance. Dia ada detector yang boleh measure the intensity of the light after it passes through our solution. So that's the component yang ada dalam UV spectrophotometer. Kita akan go in detail lagi dalam chapter 6. Okay, so it's mostly pressing of a button lah. You don't have to do much after you have prepared the solution. So bila dah ni, this is the printer, you print out, dia boleh tunjuk kat sini. So this is apa nama, instrument ni dia boleh set. Okay, nak test dekat wavelength berapa, tulis siap-siap lah 410, 420, 30 sampai lah 700 kalau kita nak buat kita punya test. So dia akan plot graph siap-siap kat sini. So this is graph and plot based absorbance versus intensity of light. So kamu tengok dalam lab manual, alah macam nak hilang kat dia. Go away. Okay. So kalau kamu tengok dekat point number C, dia suruh plot a graph of wavelength against absorbance maxima. So kalau kamu nak report this experiment, kamu kena plot a graph. Kamu kena dapatkan data absorbance daripada 410 nanometer sampai 700 nanometer. Okay, cari dia punya absorbance from 410 sampai 700 and then plot the graph. So the graph will look like exactly macam dalam video tadi tu. So this is apa nama, nanometer, the wavelength, absorbance, my bad. Absorbance, penyerapan, and this is the punya nanometer wavelength. So kita start from 410 dekat sini, sini 700. Sini absorbance kita start from 0, kita tekanlah kat sini 1.5. So it's very little lah, 0.1, 0.2, 0.3 sampai lah 1.5. So the general, yes, the general plot of the graph will be looking like this. Dia akan naik and then dia akan turun. So the expected absorption maximum for potassium permanganate adalah 530 nanometer. So the highest absorbance should be around 530. So sama macam dalam video tadi, the graph yang ditunjuk, dia akan naik melengkung dan turun ke bawah. So there will be a maximum absorption at a certain wavelength. Okay, so kita boleh gunakan this trait, this absorption maximum ni sebagai ciri untuk kita kenal pasti. Okay, that is paracetamol because the punya absorption maxima is at so and so. Okay, this is potassium permanganate because the absorption maxima is at 530. So how do we know it's 530 for potassium permanganate? This is because many people have validated this. Maksudnya orang ramai dah buat test macam ni and dia dapati okay, potassium permanganate absorb paling banyak cahaya dekat 530 nanometer. Paracetamol, API untuk Panadol absorb paling banyak cahaya at 370 nanometer. Untuk chlorpheniramine malate absorb paling banyak cahaya at so and so. So all these results, all this reading have been validated previously by multiple organizations, multiple people lah, multiple research and experiments. So that's why dia dimasukkan dalam pharmacopoeia sebagai satu ciri yang kita boleh gunakan sebagai tanda ukur. Okay, so that is basically absorption, determination of absorption maxima of potassium permanganate. Experiment number 6. Dan now our last experiment, masih lagi dengan UV visible spectroscopy, kita nak determine the calibration curve. So why do we need to determine the calibration curve pula? Okay, kat sini objektif dia kata to determine the calibration curve for potassium permanganate. Same solution macam experiment number 6. So kalau dalam makmal kita akan do experiment number 6 and 7 together. Apa nama? Why do we need to determine the calibration curve? So this is to make sure that our solution and our instrument is working as it should. Is prepared. Kalau kita nak test kita punya standard solution, dan kita punya UV spectrophotometer. So why do we need to determine the calibration curve and what is the calibration curve? Okay, so kita go through each step. Before kita kupas yang saya cakap tadi tu, saya nak tunjuk ni dulu. So bila kita buat test using UV visible spectral photometer, we are going to need these two things lah, our standard solution dan kita punya instrument UV spectral photometer. So the results of this analysis depends highly on the quality of our standard solution dan juga kita punya instrument. So kalau kita punya standard solution is not good, katakanlah macam dia tak stabil ataupun dia punya quality dah nak expire. Okay, standard solution is only good for a certain period. Contohnya macam 2 minggu, 3 bulan, depending on the material lah, depending on the compound. Tapi dia ada expiration date. So kalau kita punya standard solution tu dah way past dia punya expiration date, so the quality is not good. So kalau kita guna dia sebagai our standard solution, our final reading, final result may not be good. Okay, sama juga dengan UV spectral photometer, kita punya instrument. Kalau dia dah lama tak calibrate, it may not be good. So the final result of this analysis depends a lot on the quality of our standard solution dan juga UV visible spectral photometer. So that's why kita nak determine the calibration curve. So why do we want to determine the calibration curve and what is a calibration curve? So kat sini I want to introduce to you the Beer-Lambert's law. Okay, so this is the law that basically how this instrument operates. Okay, UV spectral photometer operate based on this law, Beer-Lambert's law. So basically what Beer-Lambert's law states, dia mengatakan secara kasar, as the concentration of solution increase, the absorption will also increase. Okay, lagi tinggi kepekatan kita punya larutan, lagi tinggi kebolehan dia untuk menyerap cahaya. Okay, so this is the law at which our instrument operates. Kita punya UV spectrophotometer beroperasi based on this law. There's a equation, kalau kamu tengok dalam kamu punya lab manual, ada. Oh, tak ada. Dalam lab manual lama ada. Beer-Lambert's law, there's an equation. That's basically the algorithm. Beer-Lambert's law. So this is the formula. The absorbance equals to the molar absorptivity of our sample, the length of the light path, and the concentration. So kalau kita nak simplify, the absorbance is directly proportional to the concentration, meaning the higher the concentration of our solution, the higher the absorbance, the higher the ability of the solution to absorb light. Okay, going back to our contoh. Okay, so this is the Beer-Lambert's law. So we can test the Beer-Lambert's law of our instrument by determining the calibration curve. So kalau kita nak pastikan kita punya instrumen tu beroperasi dengan baik, kita boleh test dia punya Beer-Lambert's law. Bukan test dia punya Beer-Lambert's law, test dia punya ability untuk patuhi Beer-Lambert's law. So how do we do that? We can determine the calibration curve. So how do we determine the calibration curve? Kita buka lab manual. Kat sini kita akan prepare 5 solutions of different concentration. Okay, solution yang sama iaitu potassium permanganate, tapi dia punya kepekatan berbeza. Maksudnya kita ada 5 solution kat sini, satunya sangat-sangat cair dan dia paling tinggi, dan satu lagi kat ujung paling pekat lah. Okay, this is the unit for concentration. Kita 10 mg per milliliter, 20 mg, 30, 40 dan 50. Okay, 10 mg per milliliter meaning dalam 1 milliliter of the solution ada 10 mg of potassium permanganate. Kalau saya nak visualize for you, Kalau kita prepare 100 ml. Okay, so solution number 1, katakanlah this is volumetric flask, 100 ml. So dalam 100 ml ni ada 10 mg tadi kan. So kalau 10 mg per mil, so that means inside ni ada 10 darab dengan 100, ada 1000 lah, my bad, 1000 mg. 1000 mg per 100. So dalam 100 ml potasium permanganat ni ada 1000 mg potasium permanganat. Ada 1000 mg potasium permanganat dalam 100 ml air. Kalau solution number 2, 20 mg per mil, maksudnya kita ada 2000 mg per 100. Basically 2 gram lah. Okay, saya simplify. Solution number 3, kepekatan dia 30 mg per mil, meaning kita ada 3 gram dalam 100 ml. So kita akan prepare sampailah kita ada 4 gram per 100 ml, dan juga kita ada 5 gram per 100 ml. So as you can see, kandungan potasium permanganat dalam setiap satu solution ini bertambah. Ada 5 concentration. So kita akan test. The idea is absorption paling banyak akan berlaku dekat ni lah, 5 gram per 100 ml solution ni, because dia mempunyai kepekatan yang paling tinggi. So after you have prepared all 5 solution, kamu just masukkan each of them dalam UV spectrophotometer and then ambil bacaan absorbance. So the absorbance here, kalau kita punya Beer-Lambert's law, kalau nak make sure dia patuhi Beer-Lambert's law, the absorbance should increase as the concentration increases. Okay, because that's what Beer-Lambert's law states. Okay, the higher the concentration of our solution, the higher the absorption will be. Kebolehan sesuatu larutan itu untuk menyerap cahaya akan jadi lebih tinggi kalau dia mempunyai kepekatan yang lebih tinggi. So the absorbance kita expect to increase as we go through our standard solution. Kemudian kita kena plot a graph. Oh, kenapa dia lari? Kemudian kita kena plot graph lagi sekali. Okay. Point number 3, plot a graph of concentration versus absorbance. So the R2 value should be not less than 0.9. So the idea is kalau kita dapat a set of data, saya nak lukis satu table. Okay, katakanlah solution number 1, 2, 3, 4 and 5. The absorbance will increase as the concentration increase. Katakanlah kita kat sini 0.23, sini 0.35, 0.39, 0.45, 0.60. So kalau kita nak plot a graph between absorbance dengan concentration, kita akan dapat satu graf yang berkadar terus. Jadi dia akan straight line ataupun close to a straight line. How do you determine whether dia patuhi Beer-Lambert's law or not? Kamu kena cari dia punya R square. This is the statistic lah. Should not be, it should be more. R square should be more than 0.99. Okay, so kalau kita dapat satu line straight macam ni, a linear graph between absorbance and concentration, that means your standard solution tadi patuhi Beer-Lambert's law. So kalau kita dapat satu set of data yang patuhi Beer-Lambert's law, meaning our standard solution is in good quality and kita punya instrument is also in good condition. Okay, so that is the purpose of us determining the calibration curve for a certain solution. Sudah, beres, habis. So kalau kamu nak state the report, kalau kamu nak report this experiment, you have to plot a graph lah. Okay, tapi disebabkan kita tak buat dalam lab, Saya dah publish pagi tadi online assessment untuk kita punya online practical class. So dia akan cover from experiment number 1 sampai experiment number 7. Ada about 15 questions. So dia akan cover everything yang kita dah cover sepanjang minggu ni. Okay, so you can go to your Google Classroom, tengok bahagian classwork. Oh, sorry, excuse me. Tengok bahagian classwork. Saya dah publish tadi. So it's due March 18. Kamu ada about seminggu untuk siapkan this assessment. Okay. Okay, dah. Each of them dah ada. So biasalah untuk kita punya online practical class. Nanti saya akan upload this final video dalam Google Classroom, so kamu boleh refer. Ada any questions?
Nak tanya. Sir nak tanya.
Ya.
Untuk cohort 14, kita chapter 5 sampai 8 kita tak habis belajar lagi.
Ya.
Tapi kita tak ada kelas dengan sir. Macam mana?
Tak ada kelas
final?
Ada lagi kan? Lepas ni kan? Plus kita ada kelas ganti lagi.
Tak ada sir.
Maksud kamu dah habis dah? Tak ada kelas lepas ni? Kamu punya exam week start bila?
Exam week start, sekejap. Saya check. Exam week start 7 hari bulan.
7 hari bulan 3?
Yes, minggu depan.
Okay. So kalau kita habis dekat chapter 5 saja kan? So
5 sampai 8. 5 sampai 8 belum.
Okay, so don't worry. Kalau kita the final test akan cover ni lah 1 until 4 saja.
1 until 4 saja. So 5 sampai 8 tak ada ya?
Ya.
So tutor tu pun tak payah buat layar?
Tutor mana? Saya belum publish kan? Betul. Yes.
Okay. Thank you sir.
Okay. Thank you. So any questions tentang online practical class? Tak ada? Okay, so kamu untuk online practical class, kamu hanya perlu buat that online assessment yang ada dalam Google Classroom sahaja. Okay, so untuk cohort 15, saya nak address, kita ada like 3, tak salah saya kelas ni ganti because the last 2 weeks saya kena COVID, so saya dah cancel kelas. Okay, so that will be announced later lah. Sekarang pun kita start dekat chapter 2 and chapter 3. Kita baru masuk chapter 3. So kita ada about 2 or 3 classes yang kena ganti. So nanti saya akan announce tarikh dia. Tapi for now kita follow dulu lah masa plan yang date yang ada dalam masa plan. Okay, cohort 15, clear? Alright.
Okay,
so, kalau tak ada apa-apa dah, itu saja. Sekian. Terima kasih. Thank you for joining.